Hey guys, here we are, chapter 17, section 1B, right? Had to split it up into two, there's just a lot here. Still talking about energy resources and fossil fuels. This section is just going to dig a little deeper into the actual fossil fuels, coal, oil, natural gas. Here is your essential question. How are fossil fuels harmful to the environment? Everything has its benefits and its disadvantages. So your question today is just, how are they harmful? Well, let's talk coal. Most of the world's fossil fuel reserves are made up of coal. Just when we talk about them in general, we still have a lot more coal left in the ground than anything else. It is relatively inexpensive and it needs very little refining after it's been mined. Basically, you dig it out of the ground and it's good to go. So we get a high net energy out of it. We don't have to do any more refining. Asia and North America are particularly rich in our coal deposits. There's still a lot in the ground and we're still pulling it out and burning it. The graph I'm throwing up back here is, as it says, energy production by source. Where are these areas getting their energy from? So the blue is coal. Now when we look in Asia, coal is where they're getting most of their energy. Then oil in orange, blue is natural gas, purple is nuclear, and green is renewable. So Asia, getting a fair amount from renewables. Europe, less from coal than oil, natural gas. They don't have as many oil reserves, so they rely on some of the others. The Middle East, oil. Oil. They're sitting on rich oil wells, oil and natural gas, where they're getting almost all of their energy consumption and using a good bit. North America, coal, oil, and natural gas. We're fairly even on those, but this is, most of our energy. When you stack all those on top of each other, and with an awful lot. Then nuclear, with renewables being our least. Now these figures are about 7 years old. Our renewables are coming up a little bit from that. They're moving up, but still fossil fuels predominantly. South America, not much coal, but they have more oil reserves, so more oil from it. And then getting into Africa. Africa, once again, higher oil reserves. Some of the OPEC countries, Libya, etc., have oil, and their renewables are higher. A lot of the areas don't have access to much and use more in the way of water, solar, and wind power. But just an idea of looking at some of them. Now, the pie graph I'm throwing up here, this is the United States specifically. Almost half of our electricity is coming from coal. Now this number's come down a little bit and our natural gas has gone up a bit, but our renewables hasn't grown much. It's growing some, but not drastically from these numbers. But this is United States use of it. Once again, about half from coal, 25% from natural gas. Oil, once again, we don't get much of our electricity from oil. It's typically burning coal, nuclear, natural gas. Oil, we're using that in transportation by and large. Coal, one of our big energy producers. Most of our electricity, right? Our lights, electricity, computers, you name it. Now the environmental effects of coal mining vary. If it's underground mining, subsurface mining, then there can be very minimal effect on the land at the surface. However, a lot of these surface coal mining remove entire tops of mountains to reach the coal deposits. And a lot of research actually goes into locating the most productive and clean burning coal deposits, because not all coal is actually created the same. It leads to air pollution and the quality of coal varies. Higher grade coals, such as bituminous coal or anthracite, these produce a lot more heat and less pollution than a lot of our lower grade coals, such as lignite. So not all coal is created equal. Actually, it's not produced under the ground equal, right? More heat, more pressure produces a higher variety of coal. Less pollution, more heat. And as we dig it up, it depends on what we get. We can use it all, we can sell it all, we can burn it all, but some is just less quality. Sulfur is really one of the big problems. It's found in all grades of coal. And this can be a huge source of pollution when the coal is burned. Now, we burn the coal, a lot of particulate matter gets thrown up into the air, the hydrocarbons, soot, etc. And sulfur dioxide is one of these. And this creates air pollution. Sulfur dioxide, SO2, H2O plus SO2 yields H2SO4, sulfuric acid. This comes down as acid rain. So whenever we're burning coal, 45% of all of our electricity coming from burning coal releases lots of sulfur dioxide into the air. What goes up must come down, and it comes down in the form of acid rain. Acid rain, acid snow, acid sleet, acid fog, acid precipitation. So without proper pollution controls, this is a real serious problem. And in places like China and India, where they don't put as much priority on scrubbing out the pollutants from the coal, the smokestacks, it's a big problem. However, cleaner burning coal technology has really dramatically reduced the air pollution in countries like the United States. In the 50s and 60s, LA had some of the worst air quality in the world. 1970, we introduced the Clean Air Act. We had to put in electrostatic precipitators and scrubbers in our smokestacks. These things specifically pulled out the particulate matter, cut way down on our air pollution. So the technology exists, but not every country really uses it. There's a cost involved. Well, from coal, let's go into petroleum, also known as crude oil. Petroleum, crude oil, one and the same. Now, petroleum is a liquid mixture of these complex hydrocarbon compounds. Similar to coal, but it's a liquid instead of a solid, a rock. And we use this as a fuel source. Now, anything that comes from crude oil, such as fuel like gasoline, diesel, kerosene, chemicals that we also get from it, styrene or plastics, is referred to as a petroleum product. It all comes from petroleum. The thing is, we just turn petroleum into various different products. And I'll get to that in a bit. Oil, how do we find it? Where is it, right? Well, we want to find it. Liquid gold, as they would say. You know, you pump it out of the ground, you make money. Now, it's found around major geologic features. Things such as folds, faults, fault lines, salt domes that get formed. These things tend to trap the oil as it moves in the Earth's crust. This leaks down through the little cracks and fissures, and then it collects at the bottom of this bedrock. Well, these types of areas where we have folds in the tectonic plates or fault lines are where it tends to collect. Now, most of the world's oil reserves are in the Middle East. Large deposits also exist in the United States, Venezuela, the North Sea, Siberia, and Nigeria. Now, Libya, Nigeria, we talk about OPEC countries. Primarily, they're going to be in the Middle East, Saudi Arabia, Abu Dhabi, Kuwait. They're in Africa, the Congo, also out of Nigeria, Libya, and Venezuela. That's what makes up most of our OPEC. These are our largest reserves. The United States also has fairly large reserves. Now, geologists use a lot of different methods to try and locate the rock formations that are most likely going to contain oil. So we study the surface and we look at these fault lines, the tectonic plates. Once we've gathered all the data that we can from our Earth's surface, then we drill exploration wells. You know, we drop down and try and determine the volume and the availability and the quality of the oil deposits. Once again, not all oil is created equal. Some have higher net quality than others, and a lot of times we realize there's probably going to be oil there, But we got to do a exploration drill to find out what kind of quality is and how much is actually there. So, just like mining, if there is enough oil that can be extracted at a profitable rate, then the wells are drilled, the oil is pumped out, and then it just flows to the surfaces under pressure. So we tap into it and it begins to work its way up. Initially, it may come out under pressure, and then we have to begin pumping it as the pressure subsides. Anyway, after the petroleum gets removed from a well, we have to transport it to a refinery. We can't use crude oil exactly as we find it. Coal, you take it out of the ground and it's good to go. You just take it off and it's ready to burn. Crude oil, petroleum, has to be refined. It has to be converted into the various fuels or products that we use. Typically in a refinery, what we do is we heat it up. Then the natural gases are the lowest boiling point, we bleed them off, and then gasoline, then aviation fuel and diesel fuel, they all have different boiling temperatures, and we pull off the different ones. And at the very bottom, the ones that have the highest boiling point, if you will, these are going to be things like tar and asphalt, what we just use for paving the roads. Now, when it comes to petroleum, we burn it, right? This is the goal of fossil fuels. They burn, we get energy from it. But when we burn them, they also release pollutants. And if you've ever lit gasoline on fire, not that I'm suggesting you do, but it gives off black smoke. These are the pollutants that come from it. Been stored in the ground a really long time, we burn it, and we release these chemicals. Now, most scientists believe, not really believe, most scientists concur that the carbon dioxide that is released from burning petroleum fuels contributes to climate change. We are in a pattern right now where the climate is changing. It is not inevitable, it is occurring. And we realize that carbon dioxide plays a part as a greenhouse gas. Now, another potential environmental effect is oil spills. It's just the nature of the beast. We're transporting it across oceans, we're drilling it up, transporting it, and it leaks out of a boat, leaks out of a pipeline, gets into the environment. Now, oil spills, like we see in a ship like this one off of Mauritania, they are very dramatic. Oh my goodness, look at that, millions of gallons of oil spilling out. We had one off the Gulf Coast with the BP oil drilling operation that broke off and that was leaking out. These are incredibly dramatic, but most of the oil pollution in the oceans actually comes from everyday sources, just like leaking cars, because a little bit drips out here, a little bit drips out here, it rains, it all washes down into the streams and the rivers out to the ocean. So even though oil spills are a reality and they're horrible, most of the oil pollution in the world is actually from on-land activities. Now, emissions regulations and technologies have really helped reduce air pollution in many, many areas. Catalytic converters are in all cars. This is pulling pollutants out of the car before it comes out the tailpipe. But when we go to drill for oil, especially in deep water or very cold ecosystems, which is increasing, we've gone after the areas where it's easier to get. We keep going deeper and deeper into the ocean or in the Arctic, colder and colder waters, and stopping leaks and trying to do cleanup effect in cold water is very difficult. The deeper the water, it's hard to get down to where the oil is leaking out. We're talking really cold water. It's hard to get volunteers out there to do cleanup efforts, right? Because it's freezing cold water. It just makes a difficulty. So as we go into more of these extreme environments, any of the leaks or spills wind up being much worse, harder to do anything about it. Now, unfortunately, measures to reduce everyday contamination of our waterways lag far behind the efforts to prevent large oil spills. The companies are vested. They don't want the oil spills. They want to be able to sell the oil. They don't want the bad press of what an oil spill looks like. They spend a lot of money to prevent the oil from leaking out. Unfortunately, when it just comes to the everyday use, you and me, there's not as much incentive for me to stop a small leak in my car, and this leads to a much worse problem. But anyway, oil in the environment causes an issue. Let's talk natural gas. Coal, a solid. Oil, a liquid. Natural gas, a gas. So fossil fuels in all three states, solid, liquid, and gas. Now about 20% of the world's non-renewable energy comes from natural gas. What is natural gas? CH4, methane. This is natural gas. Now it comes from other things. Rotting plants release methane. Dying deer in the forest releases methane. Rotting food in a landfill releases methane. Anything that dies that is a living thing, we're made up of hydrocarbons. These hydrocarbons in a chemical reaction turn into CH4, hydrocarbon and hydrogen, right? And this leaks out in the form of a gas. Gets trapped typically over oil fields. Oil bubbles up, gives off the methane, and it's trapped over it. So when we drill down, we tap into the natural gas, take that off to sell it, and we then get to the oil. It's also in coal deposits, but not as much. But when we mine for coal, methane leaks out. It's one of the downsides of these. Now, natural gas itself burns much cleaner than other pollutants. You know, you light the stove, like the picture back here. It's this nice blue flame, and there's no smoke coming off of it. You burn gasoline, you get black smoke. You burn coal, you get black smoke coming off of it. Not this case with methane. It does burn very clean. This is a benefit. Vehicles that actually run on natural gas require fewer pollution controls. They don't have to have a catalytic converter and some other mechanisms. Electric power plants can also use this clean burning fuel, and more of our power plants are using methane, natural gas, because it is a cleaner burning fuel. It still releases carbon dioxide, but not the nitrous oxide or the sulfur dioxide. So less pollutants into the air. Also, we're not releasing as many hydrocarbons, mainly water vapor and carbon dioxide. Carbon dioxide is a greenhouse gas. It is a concern, but it is cleaner than other fossil fuels. Now, fossil fuels and the future. What are we going to do? Currently, they supply about 90% of the energy in developed countries, more developed countries like North America, Europe, Oceania. As demand for energy increases, more and more people on the planet, more and more affluence, more and more desire for energy. As these energy resources increase, the cost of fossil fuels is likely to increase as well. They're limited, right? It's a non-renewable resource. As we get fewer and fewer amounts, supply and demand. As the supply goes down, the demand stays the same, the cost goes up, just common economics. So when we plan for energy in the future, it's important because it takes many years to go through a transition. We are currently transitioning to renewables, but it takes time to put all the renewable energy sources up to take over where the other infrastructure was already laid. So we have to look to the future. You know, what kind of reserves do we have? What are we going to move to? And the transition in the process. It's not always an easy transition, so we have to look at these things. And this is just what we're currently doing. Now, we need to predict our oil production, right? We need to have an idea how much is left in the ground. How long can we keep on going using the amount that we're using? Now, there's a lot of different factors that are considered when it comes to predicting it. Because when we talk oil reserves, we're talking about the current oil deposits that are discovered and are in commercial production. In other words, we know the oil's here. We know the oil's here. And we have to be able to extract it profitably. Like we know there's some oil up under the Arctic, but it's under lots of sea ice, very difficult to get to. And right now it's too expensive. But as the cost of oil goes up and our technology increases, then it becomes technologically possible to get it. So we have to kind of look at these factors. And as the price of oil goes up, more and more reserves come online. Now, it's not going to go on forever, but it's just the reality. We didn't want to get it there like oil sands. We've always known there was oil in some sand deposits. Canada has vast supplies, as does Utah. It just wasn't cost effective to extract the oil from the sand. Basically, you dig up the sand, you heat it up, and you can extract the oils. But the technology is improved, making it financially feasible, and this increases our oil reserves. So some of these deposits are now being tapped that we didn't used to use. We also have to try and look at changes in technology. As we get better technology, it might be more cost efficient to get certain oil reserves. So all predictions of future oil production are guided by one important principle: the relative cost of obtaining it by the amount that we extract from the earth. And as the supplies decrease, oil might get used more and more selectively. Once again, we may switch to more and more electric cars or cars using some natural gas, other resources, as oil gets less and less and the cost gets higher and higher. Cost gets up $20 a gallon, I probably don't want a car that's using gasoline. I'm going to switch to an electric car. It's just not worth the money. So we really may rely on other power sources for our cars and power plants, as opposed to especially oil, but some of these fossil fuels, just as the price goes up. Because in reality, very few large oil reserves have been discovered in the past decade. Now, geologists disagree about how soon the oil production from the fields is going to peak, but most people feel that it's pretty much peaked. You know, we're not really going to be pulling more out at the cost. If anything, from here on, it's going to get more and more expensive. We still have oil reserves we haven't tapped, but they're harder to get to, deeper in the ocean, colder water environments, cost effectiveness. So oil production is probably peaked, and it's only going to begin to decline. It's a non-renewable resource. It's not coming back in your and my lifetime. Now, additional reserves exist under the ocean, but it's very expensive to drill there, and the deeper we get, the more cost prohibitive it is. And global climate change is likely to make the Arctic seas more accessible, but cold water drilling increases the risk of pollution. The reality is, we desperately need to wean ourselves off of fossil fuels, move into our cleaner, renewable energies. But guys, that wraps it up for today. Come back next time and we'll talk specifically about the non-renewable energy source of uranium, nuclear power. Take care.